In a feature engineering, okay, first understand the feature engineering. Feature engineering, very important topic is a standard scaler, right? Feature engineering, when you learn about a feature engineering, that's a very crucial part of our data. So, first we understand about the standard scaler in a feature engineering, right? Feature engineering, in a feature engineering. So, we are getting with a what is a standard scalar, right? Standard scalar is a pre-processing technique in machine learning used to standardize the feature of a data set in a transformer data so that each feature and column, right? Uh, let's consider the example. We have a age, okay, age, and let's consider we have a salary, and the output is a purchase, right? So age, let's consider age is 23, 27, 35, 40, uh, 70, and we are considering the salary is 50K, 15K, 30K, 40K, uh, 35K, and 50K. Okay, this is the salary, and we are predicting the purchase of the purchase. We are they we have any product, and they based on the agent's salary, they are purchase or not. Okay, so this is our binary output. Okay, this is our binary output. So we are considering the purchase or not. So first understand age and salary. They are a different unit, right? We both are a different unit. So for we need to scale it because when we are perform our model or train our model on the different unit, so we don't get a good accuracy. Okay, for that reason we scale that particular feature. Okay, so this is a standard scaler, and similarly, the standard scaler has a okay uh, after the scalar, we are scaling the data. We have a zero mean, okay, and one standard deviation. Okay, what it means when that's the data. Okay, we are scale some point. So this belong to zero or -1 to 1. That is a feature, and different ways we are featuring the data. But in particular way, in standard scalar, there is a value is range between the -1 to 1, and that's a mean value of that particular scale value of that particular age, or you said the salary. That is the mean value. Mean value is the 0, and standard deviation is a 1. This is the basic concept. So, okay, here d is equal to 1. Then this happening is always, right? I mean, when you do any time standard scalar, you will see the mean of that particular scale value is 0, and the standard deviation is a 1. Okay. So question is why use this standard scalar? Okay. So understand with we are going with that. Why we use the standard scalar? So mini machine learning model perform better when a feature on the same scale, especially, right? So for distance based model, you know, in you perform the any model, any kind of model, you uh, any kind of model, that's a distance based. Okay, that model will be a distance based. So in that particular case, we want to use a uh, standard scalar, right? Standard scalar, because the when you calculate the distance, okay, for distance of the 2 point, let's example k nearest neighbor, that's your data points, and we are calculating distance from that point to that particular point. So in that particular case, we need we need to have a same scale. right? We need to have a same scale. For that reason, we want to scale to that particular point. Similarly, gradient descent will be logical regression or linear regression, polynomial regression. In that particular case, we are also using SVM. That particular case also we use the standard scalar. Okay, and similarly, when you study the neural networks, okay, that's also a very important thing that you will use in a use of a uh, standard scalar. Okay, without standard scalar, what is the problem when you don't use the standard scalar? So feature is a large scale dominant model, right? It's a large scale dominant model. We understand with the examples what we problem face when we not use the standard scalar. And model called when you and when the gradient descent model you perform in that particular case, the conversion rate will be slow, right? Conversion rate slow. It means that you have gradient descent, and you will convert the particular data to the previous global minima. So that conversion, right? That conversion will be very slow, and that's we don't want. For that reason, we need to standard scalar, and there's many 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 features or many columns will be standards that will be helps to model perform well. Okay. So is the formula for the standard scale is simple. Is a xi minus, that's a mean, and this is a standard deviation. Standard deviation. Standard deviation. What is the xi? Xi is nothing but xi is basically the data point, right? Is a data point. So understand that example. So let's consider understand that one example. Okay, we have a 23 3K 23 age and 15 is a data point. Sorry, salary, right? So in that particular case, we are considering is a 23 minus let's that's a mean we are considering is a 32. Okay, minus 32 divided by standard deviation. Let's we are considering now uh, 10 mean is equal to 32 and we calculate, right? And this value ranging between the minus 1 to 1. There is a simple concept of calculating that particular case. And after the standardization, we get a value of minus 1 to 1. So in that particular case, the standard deviation is equal to 1 and mean is nothing but 0 after the scale, right? This is clear, and so always you will see, and we understand the example is how these things are happening, right? And similarly, the model sensitive to the feature scale with the logistic regression, linear regression, SVM, PCA is a PCA and neural network as well. When to not use the standard scalar during the decision tree when you perform a decision tree on a random for a XGBoost, they are not scaled sensitively. Okay, uh, yeah, sensitively. We understand all that machine learning algorithm how they work and all what is the concepts about that. So if the feature are already on the same scale, right? And another thing is if both the feature on same scale. In that particular point, uh, we can't use the standard scale. Okay. Understand this one more diagram of feature scaling, right? So that's the data point are distributed in different way. Okay. And let's consider that we have a mean of that particular point is that one. So after the scaling, the data point will come closer the data point come closer to the that mean of the point, right? That's the mean of the point. And okay, understand the one example that we have a data point, something like that, and let's this the age, this is the salary, right? And this is salary, this is okay. So first it is the let's consider this. We have a data point, okay, and this is the age of salary, and these are a standard deviation of salary, and this is a standard deviation of age, okay, and mean point is someone here. So let's consider mean point. After the standard, we perform the standardization. What happening? The mean, let's consider as the mean for that particular point. Okay. So mean are that. So all data point, what it means, all data pointers come closer that a mean point, come closer to that mean point. That is the after scaling. After scaling. After scaling. In a Python, when you use the scikit-learn, in that particular case, the from a scalar, no, the pre-processing input is standard scalar, and first we train a standard scalar. After that, we fit the only first one is the X train, right? Then after the fitting the X train, we just transform X train and X test. Okay, that's simple concept. You don't do something like that to fit underscore transform on X train and X test. You